we have to determine whether the following signals are periodic or not. We have continuous time as well as discrete time signals. Let's have a recap. If a signal is periodic with a time period of capital T, this will be equal to this. This is the basic definition. This will be the time period, and the lowest value of T, capital T, for which this equation holds is called the fundamental period. So this you know. In case of e to the power j theta t, what do we do? If we have to find what is the time period, what we'll do? We'll expand it like this, and this will be theta t into e to the power j theta capital T. Now this is the original function, that is, if this is xt, this is the original function into e to the power j theta t. Now this is possible only if this is equal to this, only when this is equal to e j theta capital T equal to 1. This is the condition for the signal to be periodic. Now when will this be equal to 1? This will be equal to 1 when this theta into t will be equal to 2 pi, because e j 2 pi is cos 2 pi plus j sin 2 pi, that is 1. So this has to be 1. From here what we do, we find the time period. Okay, this is the case of continuous time. I have discussed these things in detail in earlier videos, so if you have any problem you can go and check them. I'm just giving you a recap. In case of discrete time signals, this is the condition. If xn is equal to xn plus capital N, then we say that capital N is the time period, and the lowest value will give the fundamental time period. Okay, fundamental period. And in case you have this ej, let's say theta n, this is the signal, xn is this, then what we do, we expand it like this, j theta n plus capital N, that is equal to ej theta n into ej theta capital N. Now this has to be equal to 1, then only this is possible, this equation is possible. So what we do, theta n equal to 1, that will be equal to 1 for 2 pi m. In case of discrete signal, we know it has to be a multiple of this, and from here what we get, n by m is equal to 2 pi by theta. Now you know the signal will be periodic only when this ratio is rational, and the lowest ratio for which we have n by m equal to, let's say, k, that is the lowest ratio, that will give us the value of n and m, the fundamental period. So this is the theory behind this. Let's see. Let's try to solve these questions. The first question is, our xt, it is a continuous time signal, is j10t. So we can expand it like this, j10t plus t. I can directly also find the value, but every time I'll be doing from the scratch so that it goes into your mind. So this is ej10t into ej10 capital T. Now this has to be equal to 1, so that this is equal to this. So we have 10t equal to 2 pi. We know this is equal to 1 when this particular function is equal to 2 pi, particular value is equal to 2 pi. So 10t is equal to 2 pi. From here what you get, t is equal to 2 pi by 10, that is pi by 5. So this signal is periodic signal. Looking at this only, it is an exponential signal. So this signal is periodic and the fundamental time period is pi by 5. Clear? Let's see the second one. The second one is xt is equal to e to the power minus 1 plus j into t. So we put minus 1 plus j t plus t. So what you will get? You will get minus 1 plus j t into minus 1 plus j capital T. Now here you have, this is your xt only. So this is xt into, this is e to the power minus t, and then you have e to the power minus, not minus, plus jt. Now looking at this expression, you know this will be periodic. From here we can find the time period, but the issue is this one, e to the power minus t. This is a decaying exponential. So even if we find, let's say we draw this signal, let's say it's sinusoidal, what will happen? This is a decaying exponential. So it will be like this to the point where when it will reach 0. And for a signal to be periodic, it has to be periodic from minus infinity to infinity. This goes to 0. So this is not periodic. And when it is not periodic, you know you cannot have fundamental frequency. Okay. Now let's see the third one. It is a discrete signal. Xn is e to the power j 7 pi n. What we do, we put j 7 pi n plus n. So what we get? We get ej 7 pi n into ej 7 pi capital N. Now this is the original function, so this has to be equal to 1. For this to be equal to 1, it has to be equal to this 7 pi n has to be a multiple of 2 pi. This you have seen in your seen when you were analyzing discrete signals. If you have any confusion why we have multiple of 2 pi, you go to that video and understand it. From here what we get, n by m is equal to 2 by 7 pi. That is 2 by 7. That is when m is equal to 7, n is equal to 2. This is the lowest value. So n equal to 2 is the fundamental period of this signal, j7 pi n. Fourth is your xn. This is also a discrete signal. This is equal to 3e j 3 pi n plus 1 by 2 into, not into, by 5. This is the signal. This is just amplitude, so don't get confused by this. So when we put n plus n, what we'll get? We'll get 3 e to the power j 3 pi by 5. I'm writing it here only, 3 pi by 5. This is n plus 1 by 2. Okay. Now this is equal to e to the power j 3 pi by 5. Let's get this out, n plus 1 by 2. This is the original signal. And second is ej 3 pi by 5 n. So this has to be equal to 1. This is your original signal and this has to be equal to 1. That is, from here we get 3 pi n by 5 equal to 2 pi m. From here what you get? 5 into 2, 10. That is, n by m will be equal to 10 by 5 pi cancels by 3. See, 5 into 2, 10 by 3. So for m equal to 3, your n is equal to 10. So n equal to 10, this is your fundamental period. The signal is periodic and the fundamental period is 10. Now let's see fifth one. Fifth is, this is also discrete. Xn is 3e j 3n plus 1 by 2 by 5. Is that the same signal? No, we had pi here. Here pi is missing. So similar to that, we expand by n plus n so that we get 3 ej 3n plus 1 by 2 by 5 into ej 3 by 5. There we had 3 pi by 5. Here we'll have 3 by 5. So this is 3n by 5 has to be equal to 2 pi m. From here what you get? You get n by m is equal to 10 pi by 3. Now this ratio has to be rational so that your signal is periodic. This is the fundamental definition. For m equal to 3, your n will be 10 pi, which is not rational. This ratio is not rational. Therefore, your signal is not periodic. Okay. Now let's find out the time period for composite signals which are a combination of two or more than two signals. One example is for continuous time and one is for discrete time. Let's understand what we do. See, if we have a signal which is composed of 3 signals, let's say these 3. If the time period of this is t1, I'm giving you the basic concept. If this is 2 and if this is t3, the time period of this particular signal is this signal is this signal is this, and all these signals have been combined into a single signal. What will be the combined or time period of the composite time signal? This will be the least common multiple, you know LCM, least common multiple of T1, T2, T3. T1, T2 and T3. Okay. So this is how we find out time period for composite signals. So let's try to understand how we take this out. The first signal xt, it is 2 cos 10t plus 1 minus sine 4t minus 1. See, in this signal we have cosine, we have sine function. We have here 1, here -1, plus, minus, many things. We don't have to be worried about these things. The only thing we need to know is that this is a periodic signal. This is a periodic signal. These are phase differences. That is not of our concern. We are concerned with this only. This is your omega, cos omega t. You know omega, that is 2 pi by t. Here for the first signal it is 10. Let's say this is t1. So what do you get? T1 is equal to 2 pi by 10, that is pi by 5. Okay, so time period for the first signal is pi by 5, and second it is 4. See, 4 omega t. So this implies t2 is, say, 2 pi by 4. So this will be pi by 2. So the time period, fundamental period, the fundamental period for this composite signal will be, let's say, t0. That is LCM of t1 and t2. Now this is pi by 5 and pi by 2. So what you get? What will be the minimum value of the multiple for which these two will be, there will be a divisor? That will be pi. You can see pi is divisor of this, and pi by 2 is also a divisor of this. So this is pi. You know how to find out LCM. You can try that also. It comes to pi. Okay. This is how we find in case of a continuous signal. So the combined or the composite time period is pi. What is the meaning of this? The meaning is, the first signal, let's say, is this, and its time period is pi by 5. Let's say pi by 5, pi by 5. So let's say we'll have 5 such signals: 1, 2, 3, 4 and 5. This will be pi. Okay, I'm explaining you. This is pi, this whole gap. So pi by 2 will be somewhere lying here. So this signal is, second one is this. Now this is, sorry, I'm mistaken. This is for pi. So pi by 2 is here. So this is the second signal. See, this is the second signal where we have time period is pi by 2. So what is the fundamental time period of this composite signal? It is pi. That is, after pi, if you take pi, so after every pi, this whole set will be repeated. That is the meaning. In between, if you take any value, you won't find mirror image. But after pi, you'll find that this set is repeating after every pi. Okay, this is the meaning of composite signal. Now, the same holds for discrete signals. Let's see how to find out. Xn is equal to 1. 1 is what? Un. Okay. I shouldn't say un because un is 0 for less than 1. It is 1, complete 1. The signal is 1. So its time period is 1. I have discussed about a constant signal, the time period of a constant signal. You can go to my video and understand, but for the time being, understand that the time period of this is 1. Now, second, e to the power j. First of all, I'm writing the signal. Signal is 1 plus e to the power j 4 pi n by 7 plus, not plus, minus e to the power j 2 pi n by 5. So the time period for this is 1. For this, what it will be? You know, if you put n plus n, so you'll have 4 pi n by 7. I have done this in the last example, so I'm doing directly, is equal to 2 pi m. What you get? From here you get, this cancels this with 2, therefore n by m is equal to 7 by 2. So from here what you get, n1 is not n1, n1 is 1, n2 is 7. Okay, for m equal to 2, n is 7. What about this? 2 pi n by 5 is equal to 2 pi m. So what you get? N by m is equal to 5 by 1. So from here you get n3 is 5. So the time period or the fundamental period for this composite signal will be LCM of 1, 5 and 7. And you know, it is 1 into 5 into 7, that is 35. That is, if you draw like this, if this is 0, this is 35. So after every 35, this set will be repeated. If this is like this, so the same pattern will be repeated after, again from 36 to 70. Okay, this is clear to you? Let's say this question, it is a very good question. It says find the value of m, capital M, for which we have a signal here, xn. I'm writing it here. Xn is 1 minus sigma k equal to 3 to infinity. This is impulse function n minus 1 minus k. It says find the value of m for which this signal can be expressed like this as a unit step function mn minus n0. So what is the value of this m and n? 0. M and n0. Let's find out. It's a very good question. It may seem very complicated, but let's analyze it one by one. What is the meaning of this? K equal to 3, impulse function n minus 1 minus k. I have solved some questions in my earlier videos. You know how we do this. For k equal to 0, what is the meaning of this? When k is equal to 0, this is actually what? Del n minus 1. Let me plot it. N minus 1. Okay, this is, oh no, we cannot take k equal to 0. We'll start from 3. It's from 3 to infinity. So at k equal to 3, the first point, 3. So this will be n minus 4. Okay, so if this is 0, 1, 2, 3, 4. So this means this signal 1. Okay, next k equal to 4. This will be n minus 5. That is here. This is 5. Similarly, we will have n minus 6, n minus 7 and so on. So this is like this and so on, 5, 6, 7 up to infinity. This is the meaning of this signal, this part. Now, what is 1? This is 1 minus this. 1 means it is 0. Then you have this 1, 1, 1, 1, 1, 1, 1. Here also 1, 1. So it is 1 throughout. And what is this section? This is this minus this, this minus this. So when you minus it, this minus this, what will happen? If this is 4, hereafter you will have 0. The value will be 0. That is 4. This will be 0. That is the result will be from 4 it will be 0 only. And up to 3 you will have 1. 1. 1. This is 3, 2, 1. And this side up to here you have 1. How can we express this signal? What will be the value of this signal? See, this signal will be, this is this side reverse. So this is a unit step function, you know, this is unit step, and this is minus n, you know, because we have to this side only, and from 3. So this signal is basically u minus n plus 3. You can see this is this signal 0, minus 1, minus 2. So how to express this signal? This is minus n, that is it is going this side, plus 3 means from here to minus infinity. That is this signal is basically from k equal to 3 to minus infinity, we have this del n minus k. This is this signal. Okay. So when you put 3, it is del n minus 3, this signal. Then, no. This is 3 to infinity. So you cannot put 4. Then you will put 2. Or you can express it like this. K minus infinity to 3. So 3, then 2. This is more, you know, it looks correct. That was also correct, but you are able to understand it. At 3, it is n minus 3. At 2, it is n minus 2. So it is decreasing part. So this signal is basically this one. Minus n plus 3. So now you understand what is m. M is minus 1 and n0 is mn minus n0. So n0 is also minus 3 because this is plus. Okay. So when you are dealing with discrete signals, you'll have to go step by step. You'll have to plot, because when you'll plot the signal, then only you'll be able to understand it and analyze it. So solve some similar questions and these things will be very clear to you. You have studied systems when they are interconnected. This is called series connection. The input is x1 to s1 and the output is y1, which is x2, that is input to s2, and y2 is output. This is series connection. You can have parallel connection also. You can have mixed connections. Here we are dealing with this type of connection. We are given that y1 will be equal to, when x1 is the input, y1n is 2x1n plus 4x1n minus 1. And when x2 is the input to this system, y2 is x2n minus 2 plus half x2n minus 3. We have to, first of all, we have to find y2n in terms of x1n, that is this input. This output has been given with respect to this. So we have to find this as a function of this. And then secondly, what we'll do, we'll interchange the systems. That is, we'll put s2 here and we'll put S1 here, and then we'll find what will be the output. Okay, so let's see. Y2n is given as x2n minus 2 plus half x2n minus 3. Okay, but x2 is what? Y1. x2 is basically y1. And what is y1? y1 is that 2x1n plus 4x1n minus 1. We will put, or for understanding, this is y1n minus 2 plus half y1n minus 3. Now, we have y1 for n. So, what will be in terms of the first term will be this y1 n minus 2 will be twice x1 n minus 2 plus 4x1 n minus 1, and we have minus 2. So, this will be minus 3. So, this is for the first term. The second term, half n minus 3. We'll put n minus 3. So, it is 2x1 n minus 3 plus 4x1 n minus 3 minus 1, that is n minus 4. Okay, so this is the signal. Now from here you see n minus 2 is only at this place, so this is 2x1 n minus 2. What about this? N minus 3 and then again plus 1 n minus 3. So this will be 5x1 n minus 3. This and this done, and this is twice. So twice x1 n minus 4. Okay, so if the input was instead of x1, it was x, we can say the output is twice x n minus 2, 5x n minus 3, twice x n minus 4. So this is the relation between output and input. So first part of the question solved. Now second part. The second part is the systems have been interchanged. That is, now we'll put S2 here and S1 here. Obviously, Y1 will be the output here, Y2 will be output here, X2 will be input, X1 will be here, the input to S1. Okay, so I'm rubbing it and keeping this one as it is so that we are able to compare. Now, this Y2, you know the value. Y1, this is output now, Y1n, it is equal to, it's given 2x1n plus 4x1 n minus 1. Okay, clear? But x1 is what? It is y2. See, x1 is y2, y2n plus 4y2 n minus 1. So let's write the value. This is twice y2n. y2n we can write, it's x2 n minus 2. Since this is n, we don't have to worry, plus half x2 n minus 3, and x2 here is your input. Okay, so this is twice, so this is 2 and this is 1. Okay, now second part, 4 into y2 n minus 1. So 4 into this n minus 1, we'll have to put minus 1 again. So 4 x2 n minus 1 minus 2, so n minus 3 plus 4 into half, that is twice n minus 1 minus 3, so n minus 4. Okay, so what do we get? We have 2x2 n minus 2 plus, what about n minus 3? See, 4 and 1, so 5x2 n minus 3. Okay, and then twice x2 n minus 4. So if in this system, let's say x2 was x, like we did in the last example, we can just omit this 2. Now see, this signal and this signal is same. That is, even if we interchange the systems, the output will be same. Okay.